Liquid Ice. Online lessons.
Good morning, everyone, and welcome for online lessons dedicated to climate change, a problem that isn't going away. And this lesson is very special because we organize it for the occasion of the World Environmental Day, which this year's edition is organized under the theme A Global Call for Climate Action. So in fact, climate is here very important, and therefore we decided to use this occasion to conduct this lesson. And I'm happy to welcome our expert, Raymond Lee Cairns, who is analytical chemist, and he's specializing in trace elemental analysis. He works in Italian CNR, in Institute of Polar Sciences. He was a member of 3 Antarctic expeditions and is also involved in monitoring and contaminants action program of the Arctic Council. So he's involved in both poles. Today he will focus on climate change from various perspectives, not only a scientific perspective, but also societal and political or governmental perspective as well. Please enjoy the lesson. Warren, the floor is yours.
Thank you very much, Agatha. Okay, so this is part of the lesson series for the Liquid Ice project. On YouTube, there is my first lesson. Some of the slides are the same, some are different, where I explain more the principles behind climate change. As seeing as this is a call for climate action, I wanted to go in a bit more, slightly more in depth, although it's not my direct field. I think every scientist has to start to understand how to speak to people and how to speak in a way that we're taken seriously by politics and by society in general, to make sure that our voice isn't drowned out in all the other news that is happening in the world. So climate change is a problem, and it's one that it isn't going away. So first of all, again, I'd just like to point out, what is climate change? Climate change refers to long-term shifts in temperature or weather patterns. They can be natural, they can be due to sun's activity, volcanic eruptions, or they can be anthropogenic, which means man-made. Climate change refers to changes in the Earth system caused by global warming, ecosystem shifts, sea level rise, increasing wildfires, flooding, and droughts. This is a photo from Lugo in Emilia-Romagna. 2 years ago now, they had very big floods. The police were in a meeting to discuss how to deal with these floods, and the flood happened so quickly, you can see they got stuck in their building and their cars got flooded. So climate change, when it happens, can happen very, very quickly. We see it on TikTok, we see it on YouTube, that you see people filming these events happening. And what I hope is that one day it isn't you behind the cell phone filming an event that's happening right near you, because nobody expected this was going to happen. And people are still filming these events because they're so remarkable, and they're becoming more and more frequent. So that's what climate change is. And climate change at the moment is being driven by global warming. And global warming is a long-term heating trend that's been observed on the Earth since pre-industrial times, which started about between 1850 and 1900. And they're due to human activities, primarily fossil fuel burning, which increases the levels of heat trapping greenhouse gases in the Earth's atmosphere. And this term is not interchangeable with climate change, because sometimes you hear from especially climate skeptics when they say, oh, but you're trying to change, you're trying to hide what's happening, you've changed the term that is used. The two terms are not interchangeable, and one leads into the other one. So we're not trying to hide anything. But also I often say to people, scientists would be very, very happy if climate change wasn't happening and it wasn't our fault. We'd be the first person to be happy. So we're not making up just for the fun of it. So if I go to the next slide a minute. Okay. So why do I say it's not happening? It's not going away. Well, since the 1990s, mankind has started to have various meetings called COP, Conference of the Parties, which means a big government get together where they discuss how to deal with the climate change that's happening. And you can see this is how the amount of carbon dioxide has increased in the atmosphere over time, and these have been all the meetings that have occurred. These meetings have occurred over time, and they don't seem to have had any effect whatsoever, which is quite disturbing in a way. And part of the reason for that is, although this curve is CO2, it could almost be the same curve for GDP, how well the economy is doing, because the problem is that fossil fuels, since we started using them, have brought an enormous wave of wellness, of people improving their lot in life. It's a lot of energy that is given to us, almost free. You just have to dig it out of the ground. It's a big condensate of solar energy that we're now burning. We're burning it, and this energy is giving us the world we have today. And obviously people don't want to give that up. And so we've got these COP meetings that are trying to work out how we can try and separate the carbon dioxide emissions from how well the economy is doing, how well people are doing in general. So, and we've tried all kinds of messengers to try and get this message across that we want to reduce carbon dioxide emissions without destroying the earth. We tried with Margaret Thatcher, who was the British Prime Minister at the time. She gave an address to the UN General Assembly in 1989 saying that it's a problem and we should do something about it. We had our first attempt with a young child, Seven Cullis Suzuki. She was 12 years old when she addressed the Earth Summit conference in Rio de Janeiro, and she had a big effect for about 15 minutes. We tried with David Attenborough, a British documentary maker on wildlife, who just recently actually celebrated his 100th birthday, and he addressed the COP24 and COP26 and he gave very, very nice presentations, but was largely ignored as well. And Greta Thunberg was also very famous. I think she was 15 at the time when she addressed the COP meeting. So we've tried all kinds of messengers. Some have had more effect than the other, and now you've got to sit through me for 45 minutes. So I'm sorry about that, but I'm just another messenger trying to get across that climate change is something that's happening and we should do something about it, because it's not a meteorite that's going to hit us. We know what's causing it. We know what we have to do to stop. So how do we persuade the world to stop doing what it's doing? And so we have these COP meetings. So I'm not an expert on these things, so I asked Gemini, what is a COP meeting? And it gave me this nice brief summary based on the UNFCCC website. So the climate conference, a COP, they are conferences of the parties. They're an annual summit organized by the United Nations where world governments gather to negotiate agreement. There's an annual rotation, so it goes to a different country every year. It's consensus based, so everybody has to agree. There's multiple stakeholders, which means that there are people who have an interest in what's happening. We're not talking about Buffy the Vampire Slayer, who is my favorite stakeholder, but that's not important. So they have world leaders, diplomats, and they bring together scientists, activists, and indigenous groups to try and get together to sort out what the problem is and how to address it. Have they actually achieved anything? I'll leave that for you to decide together with your teachers. It's something you can look up afterwards. There's an awful lot going on in this. So climate change isn't just a scientific problem. It's also a social, economic, and very much based on humanities, because we know the problem and we need to start pushing people to work out how to do it. So COP3 was the Kyoto Protocol, which was very heavily debated for a long time. COP21 was the Paris Agreement, where we agreed to try and keep the world below 2 degrees, and some say we're already failing that as well. COP26 finalized the Glasgow Climate Pact, where with a phase down of coal power. So coal power is extremely polluting. It generates a lot of air pollution because there's a lot of stuff in coal. It's not just carbon. When it burns, it releases all the elements and all the other things that are inside the coal when they burn it. COP28 came to the UAE consensus, which was a historic pledge to transition away from fossil fuels by 2050. And the COP29 in Baku in Azerbaijan established the goal of trying to give funding of 300 billion a year until up to 2035 to try and help countries that are having difficulty reaching these goals. So the 4 pillars of COP outcomes are looking at mitigation and adaptation. So some suggestions for you for homework would be to work out what is mitigation, what are adaptation, what balance should we give to these? Because obviously mitigation means we want to reduce the amount of CO2 that goes into the air. So the more we mitigate, the less adaptation we have to do. But we don't seem to be mitigating very well, so we're going to have to start adapting. Adapting can be from putting in air conditioners in every person's home, or building seawalls like we have in Venice, financing, moving finance towards the green transition, helping people compensate for loss and damage. You could start looking up these things for yourselves. What are some of the main criticisms of the COP system? Do they seem to work? These are things that you can discuss in your class afterwards if you want to. Because the COP system comes in for an awful lot of criticisms, because obviously they take place in different countries every year, and they often somewhere quite isolated. So everyone flies in government jets, private jets, whatever. So there's an enormous amount of emissions caused by these meetings in themselves, which is quite ironic, because obviously we're trying to reduce emissions. And obviously these slides, look at them and criticize them as well, because as always, you should always think about AI responses may include mistakes. And although I looked at these slides, I looked at these sites where they came from, it's not impossible that there's something wrong with this. And so it's something to think about, some homework for you to do. Look up what is mitigation, look up what is adaptation, what ones would you like to use. Look at the COP system. Do you think it's an efficient system? Can you think of something else? Maybe do a debate at school. I don't know. But there's lots of things you can think and talk about. So they're saying, why aren't we doing anything? Obviously, there are people that are protesting in the world. There's things, people like Extinction Rebellion, Fridays for Future, the organization that started with Greta Thunberg, saying, why aren't we doing anything? And we are, but it's not enough, because the world is always distracted. We've got economic crises, there's wars, like we have a war even in Europe. There are civilians fleeing war in Lebanon and Gaza. There are increasing taxes in Africa, for example. These are just some titles I've looked up, what titles that are happening. And then we've got also things that are meant to distract us. So Kimi Antonelli winning the Canadian Grand Prix. I'm very happy about this because I'm a Tottenham Hotspur supporter, so I'm always pleased when Arsenal don't win. So there's lots of things happening in the world that are distracting us. And so it looks like we're not trying to do anything, but we need to concentrate on climate change because it's something that keeps going whether we like it or not. Another thing is, can politics adapt fast enough to the problem? Because climate change is happening so rapidly now. I don't think, in my personal opinion, obviously these are my opinions, you can think about these thinking points for yourselves, is the political system adapting fast enough to be able to combat climate change effectively. For example, the region I live in Italy is called Veneto, and in 2019 the Veneto government voted against renewable energy financing just before there was acqua alta, so the sea level came up and flooded the chamber. So while they were voting against mitigation plans, they had to abandon their voting hall because the sea level rise happened and flooded the hall, and they had to evacuate. And this didn't cause them to reflect in any way, unfortunately. They kept on going, and this is what's happening. So this is a very, very good example of politics not adapting fast enough. We now have a number of quite large-scale wars happening in the world, and these wars are causing large amounts of a huge increase in climate emissions. This is a pie chart of the climate emissions caused by a Russian's war in Ukraine. I mean, Russia's attack on Ukraine is absolutely incredible for me still, and half the emissions are reconstruction of civilian infrastructure. 24% of the emissions are caused by fires. There was the leakage from the Nord Stream 2 that's not happening anymore, and so the actual movement of troops and movement of weaponry is a small amount of the emissions, although they cause a lot of smoke, they cause a lot of gas. There's an awful lot of emissions just caused by warfare. So they're an extremely wasteful, extremely useless way of using resources. And we need to try and combat this somehow. And we have the war in Iraq and Iran, the war in Gaza, that's causing an enormous amount of emissions. And so war in itself, sometimes people say some of the wars are actually caused by climate change. They can be caused by tensions over water or whatever, and war in itself can be an enormous source of emissions, of climate gases, of particulate matter, of long-term pollutants. All this stuff goes into the air or into the water of the affected regions, and so it's an absolutely terrible thing for the planet. And this is an article that I found in The Guardian, where they looked at the Israel-Gaza war, and the emissions from the first 60 days of the conflict were the same as the emissions of the entire Central African Republic. So a conflict on a fairly small area was enough to have the same emissions of an entire country somewhere else in the world. And a lot of that is because of flights, supply flights, munitions, and then the actual explosions and land transport is a fairly small amount of that whole emissions bonanza. But so it's just to give an idea that we're all busy recycling, we're all busy trying to reduce our emissions. We walk to school, we cycle to work, while there are people in the world starting wars and causing wars that cause an enormous amount of climate damage. And I've no idea how to stop this. So it's something you could debate yourselves in your classes and between you. What can and do we need to do? I'm just highlighting the problem. So this is a call for climate action. Where should we act? Where and how? It's not just, oh, I do my recycling, I've done my part. There's enormous, it can become a very complex argument. And somebody, this cartoon was first obviously drawn in 2020 when he had these first three waves. He started off with COVID and said, watch out for COVID, this is going to have a big effect on us. And then he said the recession caused by COVID afterwards, and then there was climate change. And then in the last few years, the artist has added biodiversity collapse and Trump. I personally don't think Trump should be quite such a big wave, but it's the easiest way to integrate it probably into the cartoon. And so politics, unfortunately, does have an effect on the world, and we have to start thinking about that and acknowledging it. One way that we see it in 2014, the Pentagon concluded that climate change is a threat to security because climate change can drive migration, it can drive conflicts. People may think that, oh, if I dam this river, we've got more water for our country, but the country downstream of that dam might say, well, I don't want you to dam that river, and attack you. And so, as a very simple example, and so climate change could be a source of national tensions. And I went to click to see if I could find these reports to talk a bit more about them, and you can't find them anymore. They've been removed. And I suspect that the current administration in the United States no longer agrees with this conclusion and has removed them. And so climate change is still going on. Climate change is happening today, it's continuing, and one of the places where it's happening the most is the Arctic. The Arctic is undergoing an acceleration in climate change. There's an enormous increase in ice loss and whatever, and this is causing the ice to thin, making it a lot easier to go from west to east and vice versa through the Arctic, where once it was completely impassable. And that now means that the Arctic is becoming a focal point of geopolitical tensions. And the Arctic is where scientists like myself, we work. These are the Svalbard Islands, where Poland and Italy and other countries have scientific stations. Greenland has got various scientific stations here. I've been to the Hudson Bay and the Baffin Island to do research in the Arctic, and these areas which once upon a time were just somewhere where scientists and the people who live there go to watch climate change, to measure it and see how it's happening, are now becoming a source of tension as the sea ice starts to retreat, and all the countries surrounding the Arctic are starting to jockey for position, for dominance, to see who can and who cannot control these shipping lanes that are gradually becoming available because the ice is starting to melt. So climate change is having an effect on global tensions. And unfortunately, the National Sea Ice and Data Center has had its funding reduced or stopped. They can keep going with some of these satellite images, and other ones they cannot. And so, again, that's a decision. And as everyone knows, we know that very recently this year, in January, the US started thinking about options to control Greenland more carefully. And so obviously the people in Greenland have very different ideas about how that should go. And that was a very big source of political tension. So climate change is driving what is happening in the news now. Although it's not being linked directly to it, it is being caused by it. And so it's something that's exiting the scientific sphere and entering normal everyday life. So that's why I'm saying we need to start thinking about it a bit more and perhaps try and be a bit less distracted. And so sea ice retreat is becoming a security issue. Climate change keeps coming out of the scientific box and is affecting world stability. And obviously, whoever controls Greenland controls the shipping lanes around it. It's got natural resources. There are shipping lanes that are becoming gradually more available, and it's very strategically located because if, for example, Russia wanted to attack the United States, it would go over Greenland. Why it would want to do that is another matter, and Greenland is in the way. And so these things are starting to come to a head because there's less sea ice, so the whole area is becoming much, much more accessible. And so sea ice and ice sheet collapse are two tipping points in the Earth's climate system. I'm not an expert on tipping points, but they're a very, very interesting concept to read about. There's this paper that came out in 2025 by Professor Rogström, diagnosing Earth's tipping points, where we stand in the Anthropocene. And this article is open access, so it means that you can download it yourselves. You don't have to pay to read it. I would invite you to have a look at it and start to understand what tipping points are and what they mean for us and the Earth's climate system. So a tipping point, according to the IPCC, a tipping point are critical thresholds in the system that, when exceeded, can lead to significant change in the state of a system, often with an understanding that change is irreversible. In essence, climate change tipping points are elements of the Earth system in which small changes can kick off or reinforce systems that are already happening and tip a system from one stable state into a very different other stable state. So some of the main tipping points that were identified in this paper, a lot of them happen in the Arctic. The Arctic is extremely important from a climate change point of view. There's Nordic forest expansion. Boreal permafrost is starting to thaw and releasing all the stuff that was in the permafrost. The Greenland ice sheet is starting to collapse. There are ocean currents are starting to slow down or collapse, or could happen depending on the temperature change that happens. Some of the ones that aren't in the Arctic, we're looking at also Antarctica. The West Antarctic ice sheet could collapse. The East Antarctic ice sheet may collapse, but that would happen at a much higher concentration of CO2 than is happening now, or much larger level of warming, because the East Antarctic ice sheet is over 3 kilometers thick and is quite stable, thankfully, for the time being. Other tipping points would be the moving of the Sahel and increased desertification or greening of different areas with monsoon season shifting. The Amazon forest could start experiencing a dieback as transpiration starts to reduce. So these tipping points are very important points in the Earth's system that could cause big changes very rapidly. And so these tipping points, when these tipping points are hit, the Earth will go to a new normal. So we started off in the Holocene, and we are like Sisyphus pushing our marble up the hill, and we're pushing it. But where are we pushing it to? We've got a current event horizon, and could we go into a safe climate condition where we've got Holocene-like conditions? That means conditions like where we started from, where we've got warmer and we start to act, we understand the problem, and we try and mitigate, and we land in a system that is safe. Or are we pushing the Earth to an unsafe hothouse Earth future where everything is too hot, we can't adapt anymore, people start moving to try and escape the hot hell where they grow up? My hope is we land in a safe future where we don't need to do anything like engineering or whatever to try and keep the planet safe. My personal opinion is we need to arrive at a system where we don't need engineering solutions to keep us safe from the Earth's heat. And so temperatures always change. Why should we worry about it? Well, about 5,000 years ago, we had Otzi, who was walking around in the Alps and was attacked and fell in a crevasse. So we know during the climate optimum that there were glaciers high up in the Alps. Modern humans, this is me with my wife and daughter in the Verona Arena, getting ready to listen to an opera. We're very, very highly adapted to current climatic conditions. Events like this wouldn't be possible in other climatic conditions. Our whole civilization has grown up in the conditions we have, and we want to try and keep them the way they are. And so you can read then the Planetary Health Check, a scientific assessment of the state of the planet. This is again something that's open access. You can download it, and it shows how we're doing on various health checkpoints. Are we in a safe operating space, or are we going towards risk? Humankind looked at the stratospheric ozone and decided destroying it was a really bad idea, and so we stabilized it, improved it. With catalytic converters and other things, we've reduced the atmospheric aerosol loading, so improving. Ocean acidification is going up, and all these other indicators, they're getting worse. So biosphere integrity, modification of biogeochemical flows. I studied the one of mercury, but there's phosphorus, nitrogen, other ones. Climatic forcing is getting worse. Climatic change is getting worse. So at the moment, we've resolved some problems, but a lot of them need still resolving. So we have to think about what direction are we going and where we want to go. And a project like LIQUIDICE is part of that. It's part of the Horizon program of big scientific projects, and we will be looking at modeling impacts on the Sustainable Development Goals, how to look at data, how to keep it, how to send it to people. We'll be doing field observations and remote sensing. Well, so we're very, very concentrated on the impacts of the cryosphere on our world, because the cryosphere, the ice in our world, is important. The cryosphere is the frozen component of the environment. It's in retreat. The glaciers are Earth's thermometers, and they're showing that we're warming up. And as glacier retreat occurs, glaciers lose more ice through melting, and that means there's less ice available in the world. And that is a bad thing, because we've got some glaciers already starting to retreat. Glaciers, some we've had already the funerals for some glaciers, and there is already a letter to the future of the first Icelandic glacier that was said to be lost was the glacier Ock, and they put this plaque in 2019 at 450 parts per million of CO2, saying this is the first Icelandic glacier to lose its status. In the next 200 years, all the glaciers in Iceland are expected to follow the same path. This monument is to acknowledge that we know what's happening, what needs to be done, and only people in the future will know if we did it or not. And so that's quite an important thing to put down. And there was a paper that came out in 2026 this year, again open access, so you can download it and have a look. It's got some not very helpful graphs, but it's an important paper, and it's showing that peak glacier extinction in the mid 21st century peak glacier extinction will start occurring by the middle of the 21st century. We've got a very short period of time to stop this happening, and glacier loss is happening all over the world. You can go to this Greenpeace report and see images from around the Svalbard Islands showing how ice retreat has happened. This is a photo from 1967 showing where the ice was and where the ice was in 2024. This is 1966 I won't even try and pronounce that. That's the problem with working in the Svalbard. Everywhere's got a very strange name, and my English tongue is very bad at pronouncing them. But we have this island. The ice once reached down all the way here, and now the ice has retreated this far. And looking at these glaciers, looking at these photos, you can see quite easily that glacier loss is happening. And it's not just happening in the Arctic. This couple went on their honeymoon to Switzerland on holiday, and they took this picture. 15 years later, they went back and they found the ice lost. You can see the glaciers retreated, and the guy put the photo on Instagram and started getting attacked, saying it's not true. He's a liar. He's getting abuse on X because his photos were showing a staggering change in the Alps. All he did was posted 2 photos from 2 different times, and that was enough for some people to start attacking him. So it's very strange, and it's not just happening in the Arctic. And between 2002 and 2023, the GRACE satellite mission measured ice loss between Antarctica and Greenland, and it showed a big amount of ice loss. And this is a short video, and these areas are showing where the ice loss is happening, because as these satellites went over, they could measure the reduction in ice. And annually, Greenland is losing about 270 gigatons a year of ice. Antarctica is losing 142 gigatons of ice, And this ice loss is mostly happening on the West Antarctic ice sheet in Antarctica, whereas it's happening all around Greenland. Because the problem is when sea ice retreats, the sea ice acts like a brake on the glaciers, and when the sea ice not there anymore, there's nothing stopping the glaciers flowing into the sea more rapidly, and so the ice doesn't melt in the Antarctic. It starts calving icebergs that then melt somewhere else. This is another video. This is a video of a glacier in Alaska, and it's showing the same thing. This is a time lapse, and you can see it's not just surface area, but it's also volume of ice is reducing. So the glacier is getting thinner and retreating backwards. And when you see things like this, it becomes really, really clear. Ice is a very good indicator of what's happening, in my opinion. And we need to take very careful consideration of what the ice is saying and showing to us. So I can stop it there, I think. So it's quite obvious that ice retreat's happening. And why is this important? Well, glaciers are also the water towers of the world. They conserve and accumulate water over the winter and release it over the spring and summer during the melt season. So, for example, the Tibetan Plateau, often called the Third Pole, contains the largest volume of glacier ice outside the polar regions, and they include these two major ice caps. These are high altitude, cold ice caps that are critical water resources for a lot of people, and if they start melting and reducing in area, the glacier could start collapsing due to global warming. And these meltwaters feed rivers that supply an enormous part of the world's population. What happens when these glaciers have completely melted away? Here's the Tibetan Plateau, and these are the rivers it feeds. So we can see an enormous part of Asia is irrigated by ice from the Tibetan Plateau. And if that water starts becoming scarce, the people are going to move. And that will be a source of conflict. Already we've got problems with migration in the world. If the people start not having enough water, they're going to move because they're not going to have an option. And that is going to be a source of difficulty and possibly even conflict. And so we need to think about how do we preserve the cryosphere? How does it keep giving us this service that is so fundamental for mankind? Because the Tibetan Plateau in itself is arid with freshwater melt lakes. This is a photo taken by a colleague of mine who now works with the USGS. So the question is, will people and countries start fighting over water resources? We already have an increase in water-related violence. When, for example, Russia bombed the dam in Ukraine, it caused the destruction of a water system that also supplied Crimea. So water itself, or lack of water, can be a war aim. There's an increase in global water crisis, stress, scarcity, and can be causing conflict. And you can look at this, you can download this article and start to think about how is water stress causing problems around the world, and will it get less? How can water resources are so important? The human body is 70% water, so we can't do without it. So we have to think about how can we preserve and look after our water resources. And LIQUIDICE is looking at a small but very important part of the global water cycle. So I'll leave this with you because it pops up everywhere, with one final thought that happened last week, because climate change is happening everywhere. This was a title from a news article in the sports pages. It's insane how climate change is having an impact on the Roland Garros tennis tournament. So the poor players were playing in extreme heat last week, and it's having an effect on them. And I suspect we're going to be having even more titles like this in June when there's the World Cup, because it's going to start being too hot for people to have a World Cup in some parts of the world. So I will stop my presentation there. I hope I've given you all something to think about, and I don't know if we can open the floor for questions or anything, or whether people need to leave. But I hope I've given you something to think about, because I suspect you've had so many lessons about climate change, is what it's caused by, what's the greenhouse effect. But I also want you to start thinking about what happens next.
Thank you very much, Warren. And I believe we have time for questions from those classes that may stay with us. And there's a question. What about the damaging hailstorms and droughts in Veneto, our area? Extreme phenomena like this
is a very big problem,
demanding,
especially for the Venetian or the Veneto economy, because these thunderstorms are now happening when grapes are forming and getting ready. So if you get thunderstorms and hailstones, they damage the blooms of apples, of grapes and other flowers, and so the fruit doesn't produce afterwards. Or if they happen later in the year, they can actually damage the fruit. So if you go up into some parts of Veneto and Emilia-Romagna, they even have, so this is an adaptation, as we call it, where they have nets over all the fruit trees to try and protect them from hailstones. And it's a big problem. And there's even a small conflict in Veneto between who's in the mountains, who collects the water, and they want to use it to snow cannon the snow the year afterwards, and the agricultural people who want to have the water right now to water the plants. And it's a big problem. Even on a small local scale, there are water conflicts between where the rain lands and where people live and where they need it. So
there's another question from Irma about for which subject we could include this topic in the project-based learning in order to solve, or at least try to solve, the problem. So depending on the classes you have, because each country has different order of subjects. For instance, in Poland, it's quite often geography. In some countries, it's science.
I see the question from, does she mean, is that a year group, or is 8 to 10 the actual age of the children?
I'm not sure if the
10.
classes are, because 8 to 10 class, it's 3 classes.
But there's we've done aimed at that age group. We've done we actually worked with the theatre to produce an opera on climate change, and we're working on trying to get some of it translated. And there's lots of little experiments you can do with children. We arrange some, I don't know, some experiments where you put water in a bottle. To one, you add like an Alka-Seltzer that fizzes and releases carbon dioxide, and the other one, you don't add it, and you put a thermometer in each bottle. You put both in the sun, and the one with more carbon dioxide gets a bit warmer after a while. You can use your phones to measure reflectivity of different surfaces and think about how, I don't know, go and stand under a tree and feel how cool it is under a tree compared to standing under a beach umbrella or nothing. There's lots of things that are causing us to feel the heat more. So there's lots of little project things you can do. If you want to contact us, we can try and help.
Okay. So I think we do not have more questions at the moment. So thank you very much for today's lesson.
Okay.
If any of you still haven't filled in the form, please do that, because we need it for statistical purposes to report on the lesson. So the link was previously here on chat. And we may invite you for a next lesson that will be organized within LIQUIDICE, which will be dedicated to Greenland. And it will be conducted by Asta Monstedt, a Greenlandic researcher that works currently in Denmark for our project as a postdoc. So she will present some information about Greenland, research conducted there, and the green transition that Greenland is facing at the moment from the very first hand, because she lived there. Now she works in Denmark, but on this issue of green transition in Greenland. So I believe it will be also very interesting lesson. And it's also, again, a special occasion because it will be Greenlandic National Day. So we're trying to get every opportunity of some official days and events. So 22nd of June, the time is not yet fixed, but it will be announced on our channels. So be invited.